So you have already seen quite a few videos on simplifying fractions and adding, multiplying fractions, dividing fractions. And now we've come to 4.4 in the Redwoods pre-algebra book, where it's dealing with adding and subtracting fractions. So adding and subtracting fractions. I just want to mention a few things because, again, you've had an opportunity to look at a few videos, a few things to keep in mind, and then I just want to address denominators that have variables in them, and then we'll wrap it up. So quickly here, your book starts off talking about, again, they use pizza a lot with fraction descriptions. If I have a pizza here, another pizza here, and I divide each one of them into 8 slices, what's interesting is if I want to know, if I want to add slices of pizza, you'll notice that it's good to divide them into the same amount from each pizza, right? So 8 slices here, 8 slices here. It's easier to check, 2 slices here out of the 8 plus 3 slices here out of the 8. So let's say I want to eat 2 pepperoni slices from this pepperoni pizza, and I want to eat 3 chicken slices here, or let's say 2 chicken slices here and 3 pineapple slices, even though I don't like pineapple pizza as much. But let's just say that I want to help out by eating the pineapple, which most people don't want to eat, and I want to eat. I could be wrong on the pineapple pizza. Maybe you like pineapple pizza. But let's just use chicken and pineapple, okay? So you have chicken and you have pineapple. I like pineapple by itself, but not on pizza. So if I take 2 slices of chicken pizza and 3 slices of pineapple pizza, that means I would have had 5/8 or 5 slices of pizza total. So notice that in adding fractions, I need to have a common denominator. That's the key, so that I can add the numerators, right? So it starts out with talking about, adding, using that picture of like a pizza. And then it goes on to describe the general formula for addition when it comes to fractions. If you have common denominator, you just add the 2 numerators. If you have a common denominator, you just subtract, this numerators, subtract one from the other. So that's the beginning. It talks about that. We've discussed this before. I just want to mention this. When you have a variable in the denominator and you have a situation like this, for example, you literally keep the variable as the denominator, stays the same, and you deal with the numerator. 7 minus 5 in this case is 2. So notice that in this case, I have 7 over b minus 5 over b, and that gives me 2 over b. Let's look at this example under you try it section. I'm going to modify that a little bit here. So you have -5 minus -4 over y. Well, the negatives, this negative here and this negative here are going to interact. And so that actually becomes a positive. So you have -5 over y plus 4 over y, which is equal to -1 over y. So the numerator stays the same. Don't worry about the fact that it's a variable. The principle remains the same. When you have fractions of unlike denominators, then I described that in the video that you've already seen or that is presented to you above. You have to find a common denominator. And so I'll just briefly. So let's look at this example, 2 over 3 plus 1 over 4. So we multiply the left side by 4 over 4, and we multiply the right side by 2 over 2. So that becomes 8 over 12 plus 3 over 12, right? And that's 11 over 12. So basically, we need a common denominator in order to add them. So I just wanted to show you an example. Whatever you get for your answer, it's always important to remember to simplify it further if you need to. So your book goes on to discuss that more. Adding and subtracting fractions with different denominators does require getting a lowest common denominator. Or I will say this, if you don't know the lowest common denominator, if you use a common denominator, the key is that at the end, just make sure you simplify your work. But the lowest common denominator is better because it will keep the work more organized and in place. But I'm just saying this because sometimes I'm saying the other option. So you can use the lowest common denominator. That's what I recommend. But sometimes people just use a common denominator. So for example, if you have 5 over 7 plus 1 over 14, and let's say you forget for whatever reason, let's say you're like, oh, 14 is the LCD. But if you don't use 14 and you end up using, like, you multiply the left side by 14 over 14 and you multiply the right side by 7 over 7, I don't recommend this, but if you do it for this particular problem, you will still get the right answer if you simplify it at the end. But sometimes people are looking for a general rule that they could just use all the time. And yes, this will give you a common denominator doing what I did here, but it's not efficient. That's the problem. And that's why the lowest common denominator is better, a better route. So it's good to learn how to find the lowest common denominator. Remember, I described in the finding the GCD, or the greatest common factor, that if you have two numbers like 14 and let's say 10, you can write this out as 2 times 7. You could write this down as 2 times 5. The greatest common factor is 2 for these for 14 and 10. 2 is the greatest common factor. That's what they have in common, the greatest factor they have. But what is the LCD of 14 and 10? Here's what's interesting. You take this 2 over here, you write it down one time, and then you multiply it by this 5 and you multiply it by this 7. Why are you doing that? Because the 2 here that you took out was common between the 14 and the 10, and then the 5 and the 7 were not common, so they have to be represented, one of them each here represented. If you multiply this all together, you get 2 times 5, which is 10, times 7 is 70. The lowest common denominator of 14 and 10 is 70. Why is this important? Because now if I give you a problem like 1 over 14 plus 1 over 10, you know that your lowest common denominator is 70, right? So basically, what do I multiply 14 by to give me 70? Well, 5. So 5 over 5. And what do I multiply 10 by to give me 70? 7 over 7. So now you have 5 over 70 plus 7 over 70, and that's equal to 12 over 70. So notice we found the lowest common denominator, and then we changed our denominators to match that number, but we also had to multiply the numerators so that we are consistent, because it has to be 5 over 5 and 7 over 7, right? You can't just change the denominator to 70. You have to change the numerator as well by multiplying by the same number you used. That's how we go ahead and solve the problem. So let me know if you have any questions, but your book goes on to give you more examples. If it gives you, I do see give you a situation where if you have like a variable in the denominator in one and a number in the other one, then your lowest common denominator is just 4 times x, for example. And so we multiply this side by 4 over 4. We multiply this by x over x. So that would leave us with 4 plus x. So the answer is 4 plus x over 4x would be the answer to this problem. So notice that finding my lowest common denominator, I just took the number and I multiplied it by the variable, and that gave me my lowest common denominator. Or your lowest common or least common multiple. So they give you more examples of that, other ways to find the least common multiple. You can use the prime factorization route, which is what I use, or you can list out the factors of a number. So for example, if you're looking at 12 and 18, so you could just write, if you're looking for the LCM of 12 and 18, you just write out the factors of 12, and then you write out the factors of 18, and notice that the first one that the smallest one they have in common is the LCM. That's another approach. I like the prime factorization approach. Let me know which one you prefer also as far as the lowest common multiple route. So I'm looking through to see if there's anything else I want to add based on the examples that you're giving. They do some work with comparing fractions. If you're going to compare fractions, then of course we should definitely make sure they have the same denominator, because that's the only way we can be consistent in comparing which one is greater or less than the other. So that is something they discuss from number 121 to 132. And basically, if you're looking at two fractions, in order to tell which one is bigger, I would make sure I get a common denominator. So we have 1 over 2. Is 1 over 2 less than 1 over 3? Or is 1 over 2 greater than 1 over 3? Well, what I'm going to do is I'm going to multiply here by 3 over 3 and 2 over 2. So now I have 3 over 6 less than 2 over 6. Is that true? Not true. Or over here, it will be the same thing. It will be 3 over 6 greater than 2 over 6. And that is true. Cool. So that's correct. Thank you for your time and have a great day.